Okay, so we're going to be talking about significant figures today. The first thing we're going to do, and the focus of this video, is going to be on the rules for determining the number of significant figures in a number. The first rule is the easiest, and it's just simply that all non-zeros are significant. So I have here three numbers, and in the first number, 1.89, there are three significant figures, or three sig figs. In the second number, there's four sig figs, and then in the third number, there are five sig figs, as they're all non-zeros. Now the second rule is also fairly simple, and it says that all zeros sandwiched between non-zeros are significant. So again, I've laid out three numbers, and there are three sig figs in 101. There are four sig figs in 4009, and then in 20,081, there are five sig figs. Now we're going to get into a little bit trickier part, which is the third rule, which is all placeholder zeros are not significant. And what a placeholder zero is a placeholder zero is a zero that appears after the last non-zero in a number that doesn't have a decimal point, or zeros that appear before the first non-zero in a number that does have a decimal point. So I'm going to lay out here three numbers, just like we've been doing, and we're going to identify first the placeholder zeros. Now these are not significant. So the two zeros in 100 are placeholder zeros because there's no decimal point, and so there's only one sig fig. The three zeros in 23,000 are placeholder zeros, so there's only two sig figs in that number. And then the three zeros in 566,000 are placeholder zeros, so there's only three sig figs there. Now, when you have a decimal point, any zeros before the first non-zero is a placeholder zero. So the 0.0 and 0.08 are placeholders, so there's only one significant figure in that number. The three zeros that start off 0.0096 are placeholder zeros, so there's only two significant figures in that number. And then the three zeros that start off 0.009025 are placeholder zeros. So here there are four significant figures. That middle zero between the 9 and the 2 is a sandwich zero. So now that we have the placeholder zeros down, the last rule involving zeros is that all zeros after the last non-zero and a number with a decimal point are significant. Okay, so this is where confusion tends to come in. So I'm going to write out three numbers here: 16.0, 25.0, and 0.00780. And in the first number, all three numbers are significant. In 25.0, all four numbers are significant. But in the third number, there's only three sig figs, and that's because the first three zeros are placeholder zeros, as we saw in the last example. So there's only three significant figures. The 7, the 8, and the 0 are significant, but the placeholder zeros are not significant. Finally, the fifth rule with determining numbers of significant figures is that exact numbers, meaning counting numbers or defining numbers, are infinitely significant. Okay? Infinitely significant. That means you can take them out to how many places you want. So infinitely significant basically means that if we say 1, it means it's 1.0, 1.00, 1.000. However far you want to take it out is infinitely significant. So if you have 4 quarters in front of you, that's a counting number. You can physically count the 4 quarters out. So when we have 4 quarters, as you can see here in this drawing, well, that's infinitely significant because I can look at the quarters and say 1, 2, 3, 4. I can count them. So if it's infinitely significant, that means it's 4.0, 4.00, 4.000, etc. Defining number is one that we can use in a conversion. So when we say 1 mile is equal to 1.61 miles, the 1 mile is infinitely significant. Okay, so what that means is that it's going to be can count as 1, 1.0, 1.00, etc. But the value that is converted, the 1.61 kilometers, well, that only has 3 sig figs.